So now we turn to a problem that's a little bit more involved. F of x equals 1 over x squared. And again, we want to find the derivatives. Remember from our previous formula problem that the derivative is limit as h goes to 0 of f of x plus h minus f of x all over h. So we return here to f of x equals 1 over x squared, and we apply that. So f prime will be limit as h goes to 0 of f of x plus h. So we're going to go into that 1 over x squared function, replace x with x plus h. So we'll have 1 over x plus h quantity squared minus f of x, which is just 1 over x squared, all that divided by h. Again, these are always a 0 over 0 limit, although here it's a little less clear how that 0 factor of an h pops up into the top there. It's there, but it's kind of hidden. So we have to simplify this, rewrite this in a form where we can eventually get those h's to cancel out. And a very common algebraic technique for dealing with an expression like this is to recognize that as a complex fraction. And so with complex fractions, we can get rid of the little fractions inside of the numerator and denominator by multiplying both the numerator and denominator of the big fraction by our common denominator, which in this case is those two denominators, x plus h, x squared, and x plus h squared. And we have to do that in both the top and the bottom. And so now we're going to distribute that through. So we continue on here, limit as h goes to 0. And when we come to that 1 over x plus h squared and we multiply by x squared, x plus h squared, right, that's multiplying through. Notice that the x plus h squareds are going to cancel out and leave us with just x squared. And then minus, and then that's going to multiply by the 1 over x squared, so the x squareds are going to cancel out. X squareds will cancel out, leaving us with just x plus h quantity squared. And that's going to be over h times those two things, x squared, x plus h squared. Now we already have the h, the 0 factor in the bottom, so we don't want to combine that with stuff. We want to keep that factor. So I'm just going to write out the bottom there. So it's over h x squared, x plus h squared. Whether you think that looks better or not, it's still pretty complicated. It is actually better. Now, we want to simplify. So I'm just going to kind of recall here that we worked out x plus h squared in a previous example. That's x plus h, x plus h. So to save a little bit of writing, I'm going to come off here and remember that when I multiply that out, that's going to be x squared plus 2xh plus h squared. And so I can go back to the limit and distribute that negative sign through that problem. And that's what we're going to do here. So we get limit as h goes to 0 of x squared, and then distribute the negative sign through here. It would be minus x squared minus 2xh minus h squared. All of that's over h, x squared, x plus h squared. Yeah, it's a lot of writing. And then those x squareds will cancel out. And now we're finally into the home stretch because all that remains in the top are expressions that involve h. And so we can go ahead and factor out that h out of the top. Leaves us with h times negative 2x minus h all over h x squared, x plus h quantity squared. And we can now finally cancel out those h's, getting rid of the 0 factor. And at this point, we can say to ourselves, hey, we've gotten rid of the 0 factor. So let's now go through and let h just become 0 as we work out this limit. Okay, and so when we do that, in the top, we'll just have negative 2x minus 0, so just negative 2x. In the bottom, I'll have an x squared, and then x plus h quantity squared will just be another x squared. So that bottom would simplify to be x to the 4th, and then we do want to reduce the fraction, negative 2x over x to the 4th. reduces down to negative 2x over x to the third. Negative 2x over x to the third. So it turns out the derivative of 1 over x squared is actually negative 2 over x to the third.